Hi everyone, I am Enes Şahin. Today I am planning to give a presentation on how machine learning has revolutionized security and facial recognition technologies. In this presentation, I will use Arnold Schwarzenegger as an example to illustrate how facial recognition systems can be improved and how machine learning techniques can change performance. I will share all the steps from data processing to model selection and address critical topics such as class imbalance and model performance. Together, we will explore how these aspects can make a significant difference in security applications. Confusion matrix analysis. Top left corner true, negative, correct, non-area predictions. This area represents instance of the non-area class that were correctly predicted as non-area. The value is high, indicating the model performs well in recognizing this class. Bottom right corner, true positive, correct RNA predictions. This section corresponds to RNA instance correctly predicted as RNA the value is low, suggesting the model suggests to identify an RNA class. Bottom left corner false negative. The RNA instance incorrectly classified as non-RNA. The high value indicates frequent misclassification of RNA samples. Top right corner, false positive. These are non-RNA instances incorrectly classified as RNA. The value is close to zero, showing the model rarely makes false positive predictions for the non-RNA class. Interpretation. The model performs well for the non-area class but has difficulty identifying the RNA class. This could indicate a class imbalance problem where RNA samples are underrepresented, making it harder for the model to learn this class effectively. To improve performance, address the class imbalance using techniques like oversampling, smooth, or class weighting. Fine-tune the model's hyperparameters. Consider using a more complex model, random forest or neural networks to capture the patterns in the data more effectively. Experiment with feature engineering or additional preprocessing steps to make the patterns in the datasets more distinguishable. Importing required libraries. These lines import necessary libraries. You can see all libraries and these explanations. For example, pandas used for data analysis and manipulation. Pipeline standard scaler used for modeling pipeline creation and data preprocessing. And these are used for models training, hyperparameter optimization, and cross-validation. And this is confusion matrix, metrics used to evaluate modern performance. Seaborn and Matplotlib used for data visualization. This line reads to CSV file lfv non-rv.csv into a pandas data frame, separating features and labels. X representing the features inputs creates by dropping the label column from the data frame. Y represents the label target creates by selection the label column. Splitting the data into training and testing sets. Splits the data into training and test sets. Test sets, you can see these values of the data will be used for testing. And Y ensures that the class distribution is preserved in both the training and test sets. Importing model to use. This imports three machine learning models. You can see these machine learning models. Models destination contains the machine learning models to be used. This dictionary contains hyperparameters for each model that will be used in grid search CV to tune the models. Defining cross-validation parameters creates a five-fold cross-validation iteration key-fold with shuffling, ensuring that the data is randomly split into five parts for validation. Initializing variables for result collection. This destination will store the results of the grid search for each model. Pipe accuracy will store the best cross-validation accuracy for each model. Pipe params will store the best parameters for each model. Pipelines will store the trained models with the best parameters. Performing grid search CV for each models. This loop iterates throughout each model, creates a pipeline with scaling standard scale flowing by the models, performs grid search CV to find the best hyperparameters using cross-validation, saves the best cross-validation score the best parameters and the training models in the distribution. Selection the best model. Best model name stores the name of the model with the highest cross-validation score, and best model CV score scores the high cross-validation score, and best model info stores the best hyper parameters for the best model. Printing the best model information, Guinness name and of the best model the corresponding hyperparameter and its best cross-validation score. Evaluation the best model. The best model is used to predict the labels on the test set. The following metrics are calculated: accuracy, precision, recall, and F1 score. These metrics are printed with 4 decimal place. Visualization the confusion matrix. The confusion matrix is computed to show the number of correct and incorrect precision for each class. It is then visualized using matplotlib. The imshow function displays the matrix as an image with a color map. The label of the classes are set as non-area and area. Thanks for listening. That's all.